Alright, we're gonna try to get a hex dump converted back to its bytes, right? Like a text hex dump, or not a text hex dump, but a hex dump as in like ASCII text that represents hexadecimal values that represent the bytes within a file. We're going to take that and we're going to convert it back into actual bytes. Or we're going to try. And let's see. So what are my push-ups here? So I haven't done any. I got all my push-ups done for Tuesday, which was earlier today for me, but it's not Tuesday anymore. It's Wednesday, right? It's Wednesday. So hold on. So it is 1/24. So we are going to change the day to Wednesday. We can keep the 1/24. Yeah, so good enough. Okay, so let's get to it. I don't feel like talking much right now. I don't feel like working, actually. I'm surprised, coming down from all that caffeine. So I'm just going to listen to some music and try to figure some stuff out. And yeah, alright. Okay, to describe this really quick. So we had this storage mode thing here because we realized, hey, if it's just a PNG file, we don't have to compress or decompress it at all because, or if it's just a PNG file, it's more efficient to just hex dump the raw binary of the PNG file, right? We don't need to ever the only time we need to when we're storing compressed data, right? If we store compressed data, then we don't have to ever use load PNG, right? Because, let me make sure I'm actually recording sound here. Yes, I am. So, okay, if we are doing the most compressed version of this hex dumping, then we just store the PNG file as is, as a hex dump. When we want to reconstitute it, we just put it back into its original bytes, and now it's a valid PNG file, and you're done. So for this hex dumper, for how we really want to use it, for the most part, we never really want to, what do you call it? Chances are we don't want to, store it uncompressed. So we're writing the store uncompressed, but do we really want that? Are we ever going to use that? Or are we just making more work for ourselves? Let me think about that. So I don't know. Let me, it's getting colder. Well, because this only got in here because when we were writing this, we were like, oh crap, sometimes I realized, oh, I want this utility for hex dumping and PNG stuff, but oh, actually, wait a second, I don't actually need the PNG library to do that. But there was a point at which I was like, hey, wouldn't it be nice to pre-process the PNG file? If we're not going to use it, we really shouldn't code it, right? Because now we're just adding trouble, but we already kind of put it in there. Now, what will be the use of doing what I'm doing? So you could take a PNG file and you could save it to disk uncompressed, right? You could save it as uncompressed, an uncompressed hex dump that actually tells, that has hex codes for the actual pixel colors. You could do that. There may be some utility in that. You could take a raw hex dump of not a PNG file, but it's literally a hex dump of a bitmap, right? And it wouldn't have any information in it besides the raw bits, right? So you wouldn't be able to know the width and height from just looking at the hex dump. You would just have this array of pixel colors in a uint32 format. I could see some utility in that, but really we're kind of violating the Yagni principle by doing this. However, I already coded it up there, so I want to kind of keep the code symmetrical or complementary, or I don't know. This could be a bad idea, but I don't know. There's part of me that says just strip it out. You're not going to use it. There's another part that says, man, we're already committed to doing it. I don't know. But regardless of which decision is a good decision, the worst decision is to just sit here and think about it and worry about it too much rather than just get something done. So we're just going to keep the idea that we can store compressed or uncompressed, and the storage mode needs to be the same for both, right? So right now we're just hard-coding the storage mode, right? So we're not ever going to use the, we'll add that feature in later when we decide we want to use it, but right now we're just going to think it through so that hopefully it works out of the box once we enable this functionality that's kind of hard-coded out, if that makes sense. Okay, anyways, let's get going. Okay. So I had an idea to reduce clutter. And it's a crazy idea. But let's really lean in on the idea that we use the videos for documentation. Alright, so we got all these error messages here. And the only thing we really care about is them being unique. We're hoping this is enough to make them unique for this system, right? So numbered errors in the exact time currently. So we're checking the inputs, and we need to make sure that the length here, the length needs to be greater than or equal to 1. So right, so it can't be equal to 0, and 0 cannot be greater than it, right? 0 can't be greater than this, because if we read this backwards, naked length less than or equal to 0, right? So basically we need data. We need this to actually be data to do something with. Okay. Then after that, we have these pointers. This is where we're going to return the whatever we do. And we're emulating a pass by reference. So right here, we need to make absolutely sure that these pointers exist. So if if any of these pointers are equal to null, then we have a problem. However, when we dereference them, right, so if we do dereference on them, then we're going to expect them to if we dereference these values, we're going to expect them to then be their respective 0 values. So the integer length should be 0, and the pointer should also be null, right? Because we haven't assigned it yet, right? So these are values we're going to overwrite by passing them by reference, and we expect that when these are dereferenced, these values are dereferenced, we expect null and we expect 0. Okay. So what I'm going to try to do here is, rather than make a big comment about what's going on here, I'm going to experiment with just making everything more terse by just recording the video for it. And, you know, if you're really confused about what's going on, then you got to look at the video, right? So let's do that. Let's put, like, the video ID is, what is the video ID right now? The video ID is 124, and the time is 1:20:30. Okay, so let's describe what's going on one more time for the camera. So these are obviously input checks by the comment. And let's explain all this one more time. First of all, the inputs have to actually have some data, right? We need a non-null pointer, and we need to declare that whatever data is in that pointer is pointing at a strip of data that is at least 1 byte of data. The next thing, we're passing these by reference. Therefore, the references can never be null, so if they are equal to null, we have a problem. However, when we dereference those references, we expect the opposite. When we dereference these, we're going to expect that they are null, because we haven't assigned what they're going to be yet, right? So we're trying to pass something, we're trying to emulate pass by reference. So hopefully that makes sense. So these are these two variables right here, the variables we're going to work with. Oh god, hate that feature. So this right here, these two, and we're going to malloc this memory, and we're going to assign however many bytes we have to here, and then we'll like return it, right? So we could put this in a variable declaration section, and so I don't really know all the details yet, and I still don't really feel like working, so I just want to at least kind of get something down here. And then let's get something down here. Like, you know, like, I don't know what goes here yet. But what I do know is that when we're returning the output parameters at the end, all we're going to do is we're going to take these things and we're going to dereference them. So the way I've written them, I can actually cut and paste that. I can just say, I can take this. Right, so this is what we want to return. And this is how we're going to return our by reference values. Okay, just like that. And there, boom, got it. Okay, so as far as what goes in here, I don't know yet. So I think for now, what we really need to do, we really need to focus on, I think, is just getting this code running. Like, even though I don't feel like coding, we should at least, we don't want to leave it in a broken spot. So let's say put some big comments here. And we commented out a lot of this because we realized that some of the operations are going to have to be shuffled around to do the inverse operation, right? So naked text to PNG file is the inverse operation of the previous thing we worked on yesterday, or 2 days ago. So right now, we don't even have like a... So we're loading this file if it exists, and I think right here we're just using our... This is probably wrong. So why did I do this? Naked text here. Isn't naked text already figured out? Naked text. So there's a lot of like, I don't know what I'm doing here. So let's reason about this and hopefully figure it out. We definitely need to load a file, right? We need to load a file, and that's going to be this naked text file, right? The file path input. We got a lot of indirection here. It is actually going to be, this time it is going to be a text file. We're going to load it into file memory and file number of bytes. Okay, that makes sense. So we got the actual memory, and it's just text. Oh, got you. We don't have the naked text because it's the command. So this really here, right? And then we did naked text, naked length here. This stupid assignment here, we never designed the code to have an assignment here. We just wanted to pipe... Right, we have inputs and outputs for each function, so we wanted to pipe one into the other. It's a nice little stream here. And this doesn't look quite right, does it? Because we're like, well, why am I doing this? And the reason is everything is not... All these functions, it's not just a matter of swap the order of the... Right, when we call... It's not just do all the same code we did before in the same order, but just use the opposite functions. We actually have to think about what the actual flow of these variables are, because we're kind of like inverting the flow of the variables. And this thing that says file memory and file number of bytes is really naked text. But naked text right now needs to be casted to a different type, because we're going to load the So when we're internally using this, we don't want text to be considered a char array. We actually want it to be a byte array. Yeah, internally that's kind of what we want to do. Internally, we want to treat text files as a byte array. So we're thinking this because, oh, this is a byte array. But what we really want is we really want this file memory I guess file memory technically is like, I don't know. There's a little bit too much indirection here, you know? There's a little bit too much indirection here. I'm not a fan. There's a lot of indirection here. Maybe we shouldn't worry about it. Right? We're trying to get this file memory using the file input path, which is going to be this relative naked text string. So we're adding a lot of indirection by kind of like doing this. The idea was that we could just, you know, we're thinking that we could benefit from, hey, this name is also a file path input, right? And so we're trying to do this to kind of self-document the synonymous ways that you can reason about the variables, but I'm not sure if that's helpful. I think maybe it's just adding too much indirection, right? Because we got to click this, and then to see where it's being used, we got to be like, oh, it's file path input, it's right here, right? So it's like, is that actually useful, or is that just more indirection that's just confusing the heck out of us? Like, I do like the idea of, like, yeah, we declare everything up front so we know what we're working with. That's kind of nice. But I'm not sure if I'm really benefiting from that. But yeah, so we take so this now is, right, hex dump the ASCII string to U08 bytes. So here we go. We got this and this. And then we got the U08 array and U08, whatever the heck here. So that's good. And then once we have it dumped out, it might actually be a raw, like if we used a uncompressed binary mode, right? So if we used uncompressed, then we're going to have to compress it before we can save it to disk, because we want to save it to disk as a PNG file. Yeah? Yes, that is what's going on here. So a lot of our variables, the workflow seems to need to be, it's a little bit changed from the original function, and I'm confused. So this looks good here. So once we get naked text and once we get the U08 array, so U08 array, let's look at that for a second. So we get this U08 array and array length out, right? And then right here we're assigning these though, right? So it looks like right, because we're using extra variable here, so it looks like file memory should be on the end. I don't know. Or actually, so really what this is this is so right here, we have like a we don't have this variable anymore. But it would make sense like right here. Right? Right. Whatever array we got here, if we're not doing any compression, like if we're not if we're not doing any decompression, if we're just messing with PNG files, putting it in a hex dump and putting it back, and not needing to actually look at the actual data, like in an uncompressed way, then we can just directly kind of do this thing over here, where it's just like PNG thing here. And that also means that here, this output here, we're close. What we really want here is this. Right, so this is the final calculation, right? And then, yeah, and then right here, here's your output here. So that's just kind of weird, the way that's done. Because it's like, I never had that any... I think that, yeah, I have no clue why this... it doesn't... The data doesn't quite, like, what do we output here? Naked whatever the heck? So it's like the variable declarations. Yeah, naked text or whatever the heck. So I don't know. It's not a, the function for doing the inverse isn't as inverse in terms of what the source code would look like, I guess is what I'm having a problem with. But we can still say this is load file if exists variables. Why don't we just do that? Right, because then we can... I kind of like that a little bit better. And I'm also feeling like there's a part of me that actually wants this code to look different from the other code I was working on, because I accidentally edited the wrong code earlier because the blocks look so similar. So this load PNG encode variables right here. So I'm feeling like being a little bit more obnoxious than I usually am with my coloring, just so that I can know what I'm looking at. So should I be getting this fancy? Probably not. But here I am. Please give me something that looks different than what I've been looking at, you know? Yeah. I don't know. And then we can write it like this. And then we have the output variables, right? So okay. And then we can just take these here. It's a U08 and a I32, right? And we'll zero these out until we figure out what they are, right? So right here and right here. And we're assuming they're just going to get assigned by whatever's going on here, right? And alright, so no trickery here. If we just take a PNG file, serialize it to HEXDump, and then later we want to take that HEXDump and deserialize it, right? If that's all we're doing, then we're in this storage mode. And that's the first thing, this first storage mode we want to use. So let's just make sure that everything still compiles, because I'm sure I messed some things up. But let's just put git bash here, make sure everything compiles, and then just say, you know what, I don't feel like writing code right now. And let's try to do, right, 20 push-ups per hour. I think was our goal. I mean, we have a goal for how many per day, but we're trying to do like 20 push-ups per hour or something to like have a good metric for getting stuff done. So let's just do PHEXDUM.sh, and let's try to just get this building again. Am I in the wrong thing? Oh, / yes. Just try to get this working. Because, yeah, I figured that I probably messed up some code in some places. So, 981. Let's go look at that. Let's fix that. That's actually further up than I thought it was going to be. 981, it's probably that helper function that I was stubbing in. Yeah, so I was stubbing in this helper function and swapping the variable names. And so we're going to take the naked text. Right, we got to know the text, we got to know the length. And we're going to convert it to a U08 array. Right, so this is the inverse function of U8 array to naked text. And we did our input checks here. We want to write the code over here. Right now we're not doing anything. We put some to-do messages, that's fine. So we just want to get this running, right, to have, sometimes the hardest part is just getting started, right? So we just got to figure out I really just would like to eventually get to the algorithmic goodness and not think about, like, the order in which things needed to be done at the higher level. Conflicting types. So I believe that when we were working on this, we kind of realized that the signature can't really be, ooh, well, that's going to be bad, isn't it? So we thought that these would have like their own, the same interface. Right, a const char. But the problem is that the problem with the signature, though, was that if we're going to return if we're going to return the PNG file data, we're not null terminating it. Well, we could. we could make it easy. We could make it easy to... We could, if we wanted to, we could smack an old terminator at the end of the PNG file data somehow. To, like, if we want this, if we really want this signature, which I don't think we want, we wanted a common interface for all these functions. Which, let me just change the signature, so... Yeah. So, we gotta rethink how we were doing this. Thinking we could just return a, I think this is going to require an overhaul. So, I think things are just going to... Before things get better, they're going to get worse. Because... I think the easiest way would be to create a struct type. So, we're going to take a risk here and just start breaking more stuff, I think. Yeah. So what we really want here is in the data file. In the data file, we're just going to put this in misc whatever until I feel like it's a big enough section to split into more sections. We need a struct like AAC, so like struct AAC 2020 PHEXDUM. Look up PHEXDUM payload, right? So, because payload is 7 letters, so good enough for me. And that struct really needs 2 things in it. It could be a union. If we really wanted to be proper about this, we could make this a union. Though I'm not really... First of all, I'm not really good at using unions. I don't really know much about them. So I feel it's just adding more complexity. When we can just, use the most stable... We could just use the most stable... Well, there's a few things we could do. We could just use the most stable... If we want a common interface here... So first of all, why do these look the same? Oh, naked text versus C99 text. Got it. I think... I think we should have something like this. I don't know, U08 pointer, U08 array. This is just a... This is just a mechanism for passing things around. This is just a mechanism for passing things around, okay? And... Um, um, right, let's just find something called ask. Okay. And we can just say I do like ask array versus we can do chr array. First of all, do we have anything for that? You have array chr. I'm gonna call it ask array. Because this does kind of violate the general to specific idea, right? I know that we did that earlier, like it did U08 array or whatever. And really that should be like array U08. Yeah, like I think if we're really going general, if we want to keep the general to specific idea, there's obviously a general to specific thing going on here. I do like that, you know, in that other way we did it, the numbers were the you might want to flip this around here in the comments. But I think that this way actually makes more sense, right? Because it's general to specific, even though we didn't do it in the other code. And we should probably normalize that. But then we can do int32. Now, if we're going to do that, then we could also get the width and height, right? So here's what I'm thinking. I don't think the performance cost is really a big deal. So instead of having a union, and also not knowing really how to use unions effectively anyways, I think it would just make more sense to say, hey, right, so the ASCII array, use the length, right? But if it's U08, then it's actually like PNG data, right? Or what we could do So we could call it array PNG. The problem with that is that the payload isn't always a PNG array, is it? Well, when we're using these functions, though, I think it is. PNG file to C99 text. Yeah, the PNG file. The PNG file may have a step where it's kind of deflated, right? The PNG binary, this PNG file binary, yeah, in terms of what we're doing, we're going from a file to, or going from a binary file to a text file, but that binary file, the end resulting binary file, is always in a compressed PNG, right? Because we got to save it to disk. The one complexity I'm thinking about is having an uncompressed hex dump of the raw pixel data. So you take the PNG file on disk and you decode it before you serialize it. And now when you deserialize it, you got to take that ASCII data and turn it into bytes, right? You got to deserialize it into bytes, but before you save it to disk, you got to take those bytes and you have to re-encode it into a PNG file and put it back there. So, with these variable names, right, these are all variable names we could choose, but really, if you think about it, this is a PNG file. This is always a PNG file. Always PNG binary. Right. So in the end, right, this U08 array, it is always PNG binary data. Always binary. Right, so we got to think about what we're actually what are we actually working with? Right, the whole idea of a problem well defined is a problem half solved. So this is actually PNG file, and if that's true, then let's take these things here. Say, you know, it is a width and height, yeah. But really, it's, if you want to be more specific, it's PNG width, right? Or is that even necessary anymore? Is that even necessary? We got the PNG file. Why do we need to know that? Is that now useless information? Is that useless information? I think it is. We don't need a variable for this. So this ASCII array, or array ask, really, if we're going to be consistent with our variables, this is just, if you look at our convention for how we're converting things, right? C99 text, C99 text, or naked text, right? So instead of calling it C99 text or naked text, that parameter could be considered any text. Like if we want to keep the same naming conventions, so this would be any text, right? So C99 text or naked text, right? It would be any of these, right? Now we could think of this as array ask, right? Array ask or ASCII array, but really we really should call it any text. And then both of these, PNG file and any text, well, they're just arrays, right? They're just arrays of data, right? And it's not a file number of bytes, because this is a file, but this is just a gigantic string. So or is it? Yeah, they are both arrays. One's an array of bytes, one's an array of ASCII characters. Simple as that. Now, a lot of times when you're working with like Unihooke code or whatever, you could have text files that have headers or whatever on them. But we're not gonna consider that. So this array length is gonna apply to this or this, right? It's gonna apply to either one, and we already have bin.txt right here, and this number tells us if it's negative, it's not text. If it's positive, it is text. So I feel like right, so this is a character array. We'll save to text file, and this thing here, length Alright, so this variable here actually is either one of these, right? This variable here could be PNG file length, or it could be any text.length. It could be either one of those. Either one of those works. And let's just use this like let's kind of use this like a what do you call it? Since we already have this bin.txt thing, right? And it's a I32, and so 0 minus 1 means it's not text, and then 0 plus 1 is yes. Another way to think of this is if it's text, it's any text. We want to use any text. Otherwise, we want to use PNG file. And so we're gonna use this. So this kind of has like it's a union like this is kind of used like a union, because one of these things, either a PNG file or any text, we're just not gonna use. But it's like it's the waste is minimal, and I don't think it's a big deal. It's just like this little payload thing, right? And then in our signatures for how we're writing this code, we can take this payload here and these commands, these commands here, Alright, so the idea for the commands originally was, put in text. The input would be a PNG file, binary, or a text file, but the problem is that oh, hold on. So these things are going to take, they're going to take a path, but they're going to output data, right? Or are they not? What do these commands actually do? Let's look at that. So we are kind of lost. We don't know what we're doing. But one of these functions, this is the one we were working on, but the one that we're not working on, the one we already did, returns the actual text. It returns the actual text that we want to save to disk. So this command here takes a file and then gives us back what we actually want to save to disk. Okay, so with that, if that's the case, then these externs here, the input is fine, right? The input is fine, but the output, but when it outputs something, it really needs, I really think I almost think it should just be void, and the output should be that payload by reference. Or we could use this payload, if this payload isn't that big, right, because it's all pointers, 1, 2, 3, 4 bytes. That might be acceptable to just pass on the stack. When is a struct too big to pass by value? So I know it needs to be small, but how small? Pass by value performs a shell copy, and the value modified won't be reflected. Yeah, that's the thing. Non-trivial structures don't fit into such tiny registers. Yeah, so let's just assume, when in doubt, pass by pointer. And I'm going to make a note of that. When in doubt, pass by pointer. Yeah, let's not get ourselves in trouble here. Okay, so let me put this back up here. Yeah, so we should be passing a pointer to this. And it's going to be easier if we use it as an output parameter then. Alright, so let's take this payload here. Yeah, this sucks because we got to reorganize this a bit. So let's go define pay for payload. Right? And what we really want for these functions here, this is kind of why I had this in this section, because this is kind of like my way. This cluster of for declarations for functions is my way of creating an interface for these specific functions. Right, so usually I don't forward declare because I want strict ordering constraints, but in this case, I want to enforce an interface. And one way of enforcing an interface is, well, we just cluster all these functions together and say, hey, they have this signature, done. We have an interface. Hey, so today, yeah, so today I'm not feeling too productive, and I'm just trying to, right now I'm really just trying to get a little bit of code written before I, like, I don't know, do something else. Like, you know, get a little bit of code written, do a little bit of push-ups, and just, it's like I don't want to work on the code right now, but I just want to look at the code and figure out what to do next, kind of a thing. Like, if you ever heard of the, like, 10-minute rule, the idea that, hey, just, if you don't want to do something, just look at it. Yeah, I am about to take a break. But I'm, like, collecting some thoughts for what I want to do next. So right here, I don't know if I showed you, I kind of broke the code, but I made some code yesterday that, if we open this up, oh, okay, so if we, so I can't show you it because it's broken right now, because I'm in the middle of it, but I made a hex dumping utility, and we're gonna take a PNG file, convert it to a hex dump, so that we can encode that hex dump into the game engine to, like, encode assets, and then do the reverse, where we can take the hex dump, that's like a hex dump string, and reconstitute it back into its original bytes, and save it to disk as a PNG file, like going back and forth like that. And yesterday, I got the code to convert a PNG file to just a naked array, like what do you call it? Like this, like an array like this. 1, 2, 3, 4, 5, 6, 7, 8. Like I was able to successfully, you know, load a PNG file in, and then get out a just a file that looks like this. Right, so it has, like, all the hex values, and all these hex values are, like, encoding 4 bytes each, right? And eventually I want to just, you know, include this into an array, right? So, like, U32 my data, some number here, I don't know what the number is, right? And then we just like include it like this. I guess technically we could keep it empty because we don't know how long that's going to be. But right, so to put it into a build system where I can pre-process files, like pre-process assets, turn them into these things, and then go, you know, I can go include that file, right? Right, and that file.txt would be would be this stuff, right? And so I can have a way where I have a pipeline. So yeah, I am going to stop soon, but before I do that, I just want to figure out what I'm going to do next. So all these functions that I wrote have to have the same signature because I'm trying to make a kind of a jump table where when you select a certain command in the command line, it will select, if you type PNG to C99 text, you get this function, right? If you type C99 text to PNG file, you get this function. All these functions are in a jump table, and so they need the exact same signatures for this to work smoothly. So this signature needs to be changed to something like extern void, and then the output parameters need to be like a payload pointer, like this. It needs to be reworked like this. And the idea is that this is kind of like an interface. This is my, right, like C doesn't have interfaces, but if you were to think about how you could do an interface in C, it would be kind of like this. Just cluster all these functions together in a big section of 4 declarations, and then just give them all the same signature, and boom, you have a group of functions that all have the same interface. Or you could technically think that these implement an interface because they all have the same exact signature. But yeah, I am about to like get out of here. But I just wanted to make note of like what needs to be done next. And the scary thing is like I realize a whole bunch of code needs to be reworked from when I wrote it, because I didn't realize that I really need an interface like this where I have this payload, and this payload, it just has like either a pointer to a PNG file or a pointer to any type of text, and then the length of the array, which is the length of either this or this, depending on which we're using. And then this is going to be a flag that's going to tell us if we're using this payload as any text or the payload as a PNG file. So this is basically a union, right? It's this is basically a union because we either have, because we're not going to use all the data at any one time, right? Because or I guess this part is kind of a union. Well, I don't know, because depending on the value of this, we're going to use either this variable here or this variable here. And yeah, I have to rework a whole bunch of stuff. So, but yeah, so the scary part is that because I've just done this, I've broken these signatures. I've broken the code, right? In order to fix this, before the code is fixed, before I can refactor the code, the code's going to have to be broken for a while. And that's always intimidating, because I always like to write a little bit of code, make sure it works, write a little bit of code, make sure it works. But sometimes when you break something horribly like this, you know, you're going to have to just do a massive overhaul and have the code broken for an inconsequential, not an inconsequential time, you're going to have the code broken for a little bit while you're kind of shifting everything around and refactoring. And that is, I hate that. That always, I don't know, makes me nervous and uneasy. But I think it's what needs to be done. Factor and progress. So, I don't like to commit broken code, but right now, I need to kind of save my spot. So, and the code base isn't even finished anyway, so when I commit broken code, I just do broken commit. So like, if we ever have to roll back in the code base, I know not to roll back to here if I actually want to see something that works. So I'm going to commit it as a broken commit, right? and then I'm going to just push this up. So let me just clear here. Git push GitHub master. But yeah, I'm out of here. But good seeing you for a little bit. But I'll see you when I see you. But yeah, I do need to get out of here just because I'm not feeling it. I just wanted to pick it up for just a little bit, and then right, like try to do a little bit every day. Like even if I'm not feeling super productive, at least try to do a little bit. So I think I've done that. I'm gonna stop the stream. I'm gonna do some push-ups, and then think about how I'm messing up the code, and maybe as I'm not working, I'll think of better decisions to make so I don't dig myself into a hole that's any deeper. So later.